Hello and welcome. I'm Jean Creighton. I'm the director of the planetarium at the University of Wisconsin-Milwaukee. Here I'm in my capacity of as a member of the GLPA, the Great Lakes Planetarium Association. We have decided as a group that we want to understand better the data that suggests we have climate changing happening and perhaps even what to do about it as a group. To that end, we have three people who are going to be co-presenting today. We have Margaret Mooney, Jeremy Hoffman, and Justin Bartel. And they're going to present both NOAA data, but also what they do in their domes. And I guess we'll also hear about a program that was funded by NOAA. So I'm going to, Margaret, you can say whatever else you would like to introduce yourself, and I'm going to give you the floor. Thank you.
Great. Thank you, Jean. And thanks everyone for tuning in. As Jean mentioned, my name is Margaret Mooney. I work for NOAA's Cooperative Institute for Meteorological Satellite Studies in Madison, Wisconsin. And Jeremy and Justin are in Richmond, Virginia. So I'm going to start out and talk about climate change in the Great Lakes, and then a little bit national and the whole planet. And then they're going to talk about a new full dome planetarium show called Cosmic Climate Cookbook, which you can watch on YouTube. So SIMS, as I mentioned, is a NOAA Cooperative Institute. There are 16 of them around the country. Ours is Meteorological Satellite Studies. So everything remote sensing is exciting to us. And there's our building. We got the satellite dishes on top. If you're ever in town, come on, I'll bring you up there. It's the best view of Madison. And then, as I mentioned, Jeremy and Justin are in Virginia, which looks like a beautiful building I haven't been to, but it looks impressive. So this is a NOAA graphic called 10 Signs of a Warming World. And I'm going to talk about each of these things that are happening. This is all observed things. There's no climate modeling, there's no projections. These are things that we've observed and measured over the last several decades. And I'll start in the bottom right-hand corner. I think everyone knows or has heard that glaciers are melting and retreating. This is a worldwide event. Ocean heat content and sea surface temperature is rising. So when snow and ice melts on land, it does contribute to rising sea levels, which we are also observing. But one of the bigger factors is that warm water expands. And when water expands, that is also causing sea level to rise. We are measuring that the air temperature over land in the lower atmosphere is rising. Snow cover in the spring is decreasing. There's more moisture in the atmosphere, more humidity. And that makes sense because a warmer atmosphere holds more moisture. Air temperatures are warmer over the ocean also, and Arctic sea ice is melting. Now, in comparison to glaciers or snow or ice that melts on land, when Arctic sea ice melt, it rarely makes a difference for sea level rise. And when you think about it, it should make sense because, like, if you had a glass of water with ice cubes in it and you measured it or just observed where the top was and walked away for an hour and came back and the ice had melted, you'd see that it hadn't raised any. So Arctic sea ice is already displacing seawater. So when it melts, it rarely makes any difference to the sea level rise. But what does happen is Arctic sea ice reflects incoming solar energy. And when that is gone, more of that energy goes right into the oceans and it causes more warming. So how long have we known about this warming situation? The first American scientists to document the fact that greenhouse gases in our atmosphere would cause warming was Eunice Newton Foote in 1856. She was doing experiments on greenhouse gases. And she noted that more carbon dioxide caused warming. And she said, if we add more carbon dioxide to the atmosphere, it is going to cause our atmosphere to warm. And I first learned about her at the Wisconsin Film Festival. And the video I saw is free to watch on YouTube. If you want to Google it, it's called Eunice. So indeed, we've been tracking greenhouse gases, heat heat trapping gases since then. These are the big three: carbon dioxide, methane, nitrous oxide. And this is often referred to as the hockey stick, where for thousands of years, we know these values in the atmosphere, virtually no change. And then along comes the Industrial Revolution, and they are skyrocketing. And so it looks a bit like a hockey stick. So carbon dioxide is the one we hear about the most. It's very long-lived. Methane and nitrous oxide are actually more powerful at trapping heat, but they are short-lived. So that's one of the reasons we're concerned about carbon dioxide, because it will last in the atmosphere and have an effect for, lots of years, probably 100. Here's a resource for the Great Lakes region that I like to use that documents warming and also changes in precipitation. So these are maps from the Great Lakes Integrated Science and Assessments, GLISA. And what they did is they looked at two sets of climate normals. First, 1951 to 1980, and then 1980 to 2010. And they compared the differences between those two sets of 30-year normals. So we'll just go through each season, and you can look at the county that you live or the county that you're familiar with and see the changes. We're starting out with spring here, and you can see significant warming comparing those two sets of 30-year normals for temperature. And also a lot of places have more precipitation, some no change, and some actually saw, drying, less precipitation. But like I said, look at the county that you're interested in, you can see the changes in that location. Going to summer, there's still warming, but it's not as drastic as spring. Precipitation is all over the place in summer. Autumn, warming. Once again, not as drastic as spring, but warming everywhere. And clearly, autumn is much wetter. Winter, significant warming. And this is one thing we're definitely noticing in Madison, and mainly in the overnight lows, but significant warming during the winter season. And we're seeing here comparing these two 30-year normals that there's less precipitation in winter in the Northeast, and then more some other locations. So these are on the GLISA website, and I'll put the link in the chat in a bit. You probably heard also that NOAA released our latest climate normals last week. And so those are the 30 years from 1981 to 2010. And this is a comparison of that climate normals and the previous one. Even though these data sets overlap, they still show, for most of the country, significant warming. There's just Montana and the Dakotas that show a little bit of cooling. And then for precipitation, you can almost divide the country, not quite the Mississippi River, but there's the whole Southwest, west-southwest is drier, and almost everywhere else is wetter. Here's another way to look at that data. So this is NOAAclimate.gov created these graphics. And what they did is they looked at every set of 30-year normals, and they compared them to the 20th century average. So if you look at the temperature bar at the bottom, it's either +1 degree Fahrenheit or -1 degree Fahrenheit. But so if you look at this, you can also see the Clean Air Act. So watch this, 41 to 70, there's some cooling, 51 to 80, cooling, a teeny bit in the next one. And then when the Clean Air Act kicks in 1970, what happens is all that air pollution was putting particles in the atmosphere, and solar energy, incoming solar energy, was reflecting off it. And then once we cleaned up all that air pollution, things that were causing acid rain and other problems, the solar energy was able to get to Earth, and warming really took off. That's not the only thing going on, but that's one of the things that's going on. When you see cooling in those decades right after, the 50s, 60s, 70s, that cooling is largely attributed to air pollution. I want to share this resource for the Great Lakes region too. We created this at SIMS, and it's 26 locations around the Great Lakes region. and 100 years of data for each location. So, and it's interactive. So it's a web app, it runs on any browser. But what you can do is start out by looking at a location that you're interested in. And if you click on a decade, you can get the average annual temperature for that decade for that location. If you click on then another decade, you can see the change in that time period. You can also click on one location and get a pop-up graph and see the the annual average temperature for that location. And you can toggle between Fahrenheit and Celsius. So this is a tool that you can look at the warming in a location in your lifetime, or a student can look in the main decade of their lifetime, or 2 decades, depending on how old the student is. So this is also online, and it's just the NOAA National Weather Service data in this web app. So looking a little broader than the Great Lakes region, the United States has a national climate assessment that's put out every few years. The most recent one was 2014. You can see this precipitation map shows an increase in heavy precipitation. So that's most locations, but a significant increase in the Northeast and also in the Great Lakes. And their top 3 findings is that global climate change is happening, which I think we know, and largely due to human activities. Some extreme weather are increasing, and I better close my video. Human endorsed climate change is projected to continue and will accelerate if we don't change our emissions. So people often ask, less and less every day, but are humans responsible? So this graph and this interactive is from the IPCC 2007 report. IPCC is the Intergovernmental Panel on Climate Change. And so here, this is a climate model. So it's not the, it's one of the few other times that I'll use a climate model, but we're only using it to look back in time. So here are observations over the last century of observed temperatures, and it's the black. And then if we want to use a climate model and say, what if there weren't any humans on Earth? What should that look like? And that's what it looks like. It's this blue line. And then here are some major volcanic eruptions that, remember how the air pollution caused cooling, volcanic eruptions causes cooling for almost the same reason. Incoming solar radiation is bounced back into space and not warming up the planet. So those are there. That's a natural forcing. And then if you add humans on Earth, the model shows that it's almost the same as observed temperatures. So this is using climate modeling to show that, in fact, the only way we can account for the temperatures that we've observed is human activity. So the IPCC, they don't do any research. What they do is they look at all the research that other scientists are doing around the whole world related to climate change. And every time they put out a report, they usually have a major conclusive quote or summary. And in 1995, it was, the balance of evidence suggests discernible human influence. In 2001, most of global warming of the past 50 years is likely due to human activities, odds 2 out of 3. And in 2007, most of global warming of the past 50 years, very likely, odds 9 out of 10 due to greenhouse gases. And so the most recent IPCC report was released over 2 years, 2013 and 14. They saw the same changes that we saw in the 10 signs of a warming world. And they also had this overarching conclusion. Warming of the climate system is unequivocal. And since the 1950s, many of the observed changes are unprecedented over decades to millennia. And in fact, carbon dioxide has risen by 20% since 1958 and nearly 50% since the Industrial Revolution. And our most recent reading has CO2 in the atmosphere at 416 parts per million. You probably heard of the organization 350.org. They picked that name because 350 is what they think is the safe level of CO2 in the atmosphere. And we've blown way past that. So we know that we share this planet with 7 billion other humans, and some of us use more energy than others. So who emits the most carbon dioxide? It's the top 1% earner. I bet none of us are in that, but we're probably in the top 10 or the middle 40, and we are making a much larger carbon footprint than the poor people on the planet. And this brings us to the topic of climate justice, and that's the idea that the people that are most vulnerable are the least responsible and also suffering the most. So this map shows on the top carbon dioxide emissions from 1950 to the year 2000. And you can, the map is distorted to show who emits the most. You can see the United States is bulging. And then the bottom part of the map shows people who are affected in climate sensitive issues, whether it's malaria, malnutrition, flood-related fatalities, and the United States is barely discernible. Africa and Asia are bulging. And in fact, the World Health Organization claims climate change is the greatest threat to global health in this century. So this brings climate change into a climate justice, ethical, moral problem for all of us, hopefully be more motivated about. Another resource that I really like is Climate Central. They have multiple maps and a lot of data to provide insight about climate change in your location. And they update this every year, warming since the first Earth Day, that'd be 1970. And so this is this year. And they have the United States in April of this year, warming by 2.4 degrees Fahrenheit. I also found these locations, since some of us are in these locations, just to see, to make it more local for many of the people. But you can go to this webpage and probably find your location. It's not everywhere in the United States because once again, it's mainly National Weather Service, where the National Weather Service is collecting data. So we've been burning fossil fuels for a long time, and there's something called a commit scenario, where because of this, and because carbon dioxide stays in the atmosphere so long, some changes over the next few decades are unavoidable, and there is going to be more warming based on the carbon dioxide in the atmosphere. But beyond that, we can make a change for future generations. This is the only other climate model graphic that I've included in this talk, and it's a low emission scenario and a high emission scenario for days over 100 degrees F. So if we keep going right now as business as usual, we're headed towards the high emission scenario, which really is just drastically hot. And then even if we change, which there's lots of signs that we are, we'll still have the more degrees over 100. So what can we do about climate change? We can mitigate it, get off of fossil fuels, or remove carbon dioxide from the atmosphere. There are experiments going on along those lines to remove carbon dioxide from the atmosphere. And we know that there's a lot of efforts to get off of fossil fuels also. We can adapt, spend money to make changes because we have to, or we can suffer, and a lot of people are already suffering. There are a lot of examples of adaptation on NOAA's Climate Resilience Toolkit, and you can probably find, there's several in every state, and you can probably find one near you. But you probably also know about examples of adaptation in your community. I mentioned, I'm in Madison. Well, it involves a chain of 5 glacial lakes, and they're connected by a river. I live 2 blocks from that river and 1 block from one of the lakes. And what I've noticed in the nearly 3 decades that I've lived here is that neighbor after neighbor after neighbor are putting in sump pumps because of the heavier rain that we saw in that graphic from the National Climate Report, and flooding. So that's local adaptation that I've noticed in my neighborhood, and you probably have an example in yours. But how about this for adaptation? Indonesia is moving their capital, home to 10 million people, and they're moving their capital. Back to mitigation, I wanted to point out that the IPCC includes in their report that lifestyle and personal behaviors make a difference. But we also need policies, and I just list a few here. Everyone's heard about the Paris Accord. We're back in the Paris Accord. There's a lot of regional efforts to try to reduce fossil fuel use and carbon pollution. And you've probably heard about them also. And we'll see what happens with the Green New Deal too. I wanted to mention also Project Drawdown. So this is 100 types of activities that we are, I think 85 of them we already have and already know about them. 15 of them we are pretty sure they can happen, but they're not viable yet. But if we were to follow them, we would actually stop climate change, stop warming, and then they call drawdown the point where we actually start to reverse it. So these are the top 7, which you have probably heard of. What I like about this list is number 3 and 4, because these are ones that everyone can do quite easily. So eliminate food waste in your household. It actually sounds simple, but if you actually try to always eat everything you have to be mindful of that. And then also to shift our diets away from red meat towards plant-based foods. So these are in the top number 3 and 4 in Project Drawdown's 100 list of things to do to stop climate change. Totally manageable by everybody. And I need to mention that there are lots of co-benefits from reducing your carbon footprint, cleaner air, cleaner water, better health, and you usually can save money too. Finally, I wanted to make sure everyone knew about these climate opinion maps. So Yale has almost 20 different topics that you can search by county and find out where your neighbors are on these various topics. So, and they keep them up to date. And in 2020, 72% of American adults think global warming is happening. But these are super interesting to peruse. Wrapping it up, climate change is real, it's human caused. Experts are in agreement. It's harmful to humans, but we do have the solutions that are technically feasible, economically affordable, and politically viable. I could take questions now. You can also email me, or I can take them in the chat. And Jeremy and Justin are up next.
Thank you, Margaret. Nice to see you again.
Hi, how are you?
I'm fine. And thanks everyone for, and thanks to Margaret for that absolutely, spectacular introduction to climate change science. I'm gonna switch over to our slides and kind of show a little bit about how we apply a lot of climate information in the Science Museum world, science technology centers. We're at the Science Museum of Virginia in Richmond. I'm going to hand it over to my colleague, Justin, who's the manager of the Dome, our planetarium, a little bit later on. So you get the kind of director's cut explanation of how this process worked. And I want to say that, this is a grant that was wrapped up in 2018 and was funded by the NOAA Office of Education, their environmental literacy program. And a lot has gone on since, our initial thoughts around this work. So where relevant, I'll point to those things. The Science Museum of Virginia, pre-pandemic, we were welcoming, several hundreds of thousands of visitors every single year. This kind of picture probably gives you a little bit of maybe a little bit of disease seeing all these people. Apparently the CDC just announced that if you're fully vaccinated, you can resume normal activities as these. So maybe we're getting closer, but this was from the 2017 eclipse outside of the Science Museum of Virginia. And one of our mission is to enrich Virginians' lives through science. And one of the key programs that we focused on in the last decade or so is climate change resilience, which is the ability to absorb climate stressors and then rebound to a state that's actually more prepared and more ready to bounce back from a stressor than you were before. And that definition has actually evolved a little bit through time as well. You can read about it in a new theory of change from the Environmental Literacy Program at the NOAA Office of Education website. It started as a collaboration among a bunch of different groups. We've grown. We were like a snowball that as soon as we left the top of the hill, we kept getting new partners as it went along. But really, when we began, it was just a small group of mighty information folks. And our charge was to increase just the salience, the relevance of climate change to our audience's lives. And one of the ways that we did that was through these short animations, a minute and a half long, quick bits about climate change information, climate change papers that were coming out. We had to actually show these as little like previews in our planetarium. So we would actually project them onto the big screen as kind of like introductory videos. You can go to our YouTube and take a look at some of those if you'd like. Some of them are quite funny. We made a music video that actually we rewrote the words to Blitzkrieg Bop to be about climate change if you're a Ramones fan out there. And so check it out. Our YouTube page has a lot of resources that are quite nice in some ways for familiarizing people with climate change in a quirky, non-confrontational manner. We also hold daily, or we did, I suppose we will someday again, climate change themed docent-led interactions on our Science on a Sphere, which is a really great way to project those data sets that you saw Margaret share in a way that's really captivating and visually impressive. We also wrote a bunch of scripts and skits with our theater company that went from everything from sea level rise to cows and how they produce milk, and when they're stressed by heat, they don't do as well. And then allergies. Kim Jones Clark is now the creative director, and I put in the chat a little while ago a video to a new production that she's put out about Eunice Foote that's really quite funny and really fun. So take a look at that when you want to. Also, part of this grant was to figure out more artistic ways of presenting climate change. And you might be familiar with Jill Pelto's work, or her social media handle is Glaciogenic Art. But she took some of those data sets from the AR5 and started to animate over the top of them. So this is the glacial volume decrease from the 1960s to the relatively present. You can see this visitor has very vividly represented what this negative glacial mass balance means. It's losing ice and becoming liquid water. So this is one of the more fun things that we do in an art space that we call Art Lab at the Science Museum. We've updated this to include more locally relevant data sets. Turns out that in our evaluation of our program, the more hyper localized we could become with our data sets and interpretations, the better it was for people to feel like they could do something about climate change. It goes from very far away in time and place to being very actionable in their backyard. Some other stuff that we learned how to do were really hands-on activities that showed emergency preparedness. So what we know from climate change is that extreme weather events like hurricanes that are particularly important to our coastal and inland communities here in the Commonwealth of Virginia, they have cascading social impacts that are amplified by more intensified rainfall rates, wind speeds, and slowed down translational speeds. So we actually tried to increase our community's resilience to climate change through hands-on activities that tried to teach them skills like how to build a water filter. This actually didn't do very well in our evaluation. People were missing the link between this and climate change. I don't blame them. So we actually changed that up to be more locally relevant. Again, this is extreme hyperlocal relevance is how you get people to start really moving from awareness to action. And we worked with the Climate and Urban Systems Partnership out of the Franklin Institute in Philadelphia to adapt their Ready Row Homes exhibits to be able to be used to investigate amplification of extreme heat through the urban heat island effect, as well as ways to manage excess stormwater, which is an effect of having more intense rainfall events. And especially those two things are really, really locally important to people that experience like excessive exposure to extreme heat, and then that experience regular flooding of their like basements and streets and things like that. So by getting them to experience these ready row homes, we were really, really impressed with our ability to move people towards actual resilience behaviors, like installing a rain barrel or a rain garden, or going out and planting trees. We can talk a lot more about that, and a lot of our work since this grant has really focused on this and the environmental justice aspects of this work, which I won't get to at all in this. We learned, overall, the educators that are participating in this program, they really needed to feel extremely confident in their ability to explain not only the top level stuff about climate change, but really what are those second and like tertiary level kinds of impacts, like on phenology, or the study of the life cycle events in plants and animals. How do you describe our relative confidence in how climate change affects like the harvest of a locally relevant fruit or vegetable? And so we found that our educators were struggling with those connections. So really investing time in figuring out how museum educators can become confident in explaining climate change. One of the tactics that we used was actually allowing the facilitators to actually start creating their own narratives around how climate change has interacted with them in the past, either living through some sort of extreme weather event like a hurricane, or through some other means like if their family were farmers, or if they're outdoorsy, or whatever it may be. Really connecting the museum educator with the values of our audience was one of the key ways that we got people to feel more comfortable, not only as the audience, but as the facilitator. We also hosted talks, public talks. We had a rapper. If you don't know Baba Brinkman, he does a rap guide to climate chaos. There's our program manager at NOAA, Carrie McDougall, senior program manager at NOAA. It's really been her hard work that has advanced a lot of this resilience education program stuff in the last few years. We hosted a creative change event. It was basically an art, music, and climate science festival, where we actually got some local musicians to play climate data sets. We actually turned it into music. We also hosted a couple different art-based installations about climate change, including one about ocean acidification and coral bleaching. And we found that people were much more attuned and attentive to these messages when it was wrapped up in some creative process like art and music. That also stems into things where people get to role play. This was called Extreme Event Challenge, which is a tabletop interactive role-playing game where people can actually pretend to be emergency managers in a city and decide where different resources go in the event of different weather-related disasters. There are a bunch of these different types of tabletop facilitations that are available now out in the world, including the USDN's Game of Extremes, Game of Heat, and Game of Floods. And then the also NOAA ELP funded Science to Civics program from the Museum of Science, Boston. They all do a very spectacular job of having people recognize that there are trade-offs in the investments that we need to make in order to produce resilience to climate change. Those impacts that Margaret said we're expecting to happen in the next decade, we need to be ready to absorb those into our society. So these sorts of experiences allow people to see this problem from more than just their personal angle. They get to see it from other people's potential kind of stakeholder perspectives, which is a really neat way to get people to learn about climate resilience plans. Then we also had this thing called Prepareathon. big multi-hour free day at the museum. You know, we would get thousands of people to come to the museum, park a couple fire trucks outside. You know, people start to get really jazzed about learning about climate change resilience and extreme weather preparedness. This actually ended up elevating the museum's reputation among emergency managers and different practitioners, because we got to meet the people that were actually doing that work. So these one anecdote from a county, the Henrico County, which is just outside of Richmond, emergency manager was like, I've never gotten to actually meet someone and tell them about my job before. It was like one of those things where demystifying that process of like who you are and humanizing the people that are doing that work was a huge benefit, not only to the public people that were coming to the museum, but to the practitioners themselves. I actually really advocate now in my work that science centers and museums and planetaria, all those sorts of places that are informal science learning locations, can be these kind of perceived as a neutral arbiter or a nexus point in their community to serve for these challenging conversations. It's not a new idea, but it's something that I really try and advance when I can. We'll get to this now. The main focus of the rest of the talk, once I get through a little bit more of our evaluation findings, will be the Cosmic Climate Cookbook, and I'm going to hand it over to Justin to tell you more about the process behind it. But we also produced a full dome planetarium show where we explored the planetary context, our cosmic neighborhood context of what's going on Earth relative to our cosmic neighbors. That's also freely available and adapted for YouTube now. Thanks, Justin, for making that happen. And then, it's really good content that stretches between astronomy and really a significant like paleoclimate science. It's really amazing. You'll hear Justin tell us a little bit more about that in a little bit. Really, this work has been kind of woven throughout the work of the entire museum. It tends to be the case when you really dedicate yourself and your organization to making climate change one of those things that you're really good at doing, and do it in a bunch of different places all over the museum or all over your organization. It's like a muscle, until you work it out every day, it might get sore, it might be out of work, it might not even really last very long. But the more and more you go weightlifting or you go running, the longer you can do it. So we did get a full evaluation of this from Randy Corden and Associates, an external evaluator. Several of the programs were evaluated, including the Cosmic Climate Cookbook. And we found that the stuff that was really, really focused on the climate science, like the Cosmic Climate Cookbook, on this basically a rating from strong resilience behaviors, like does it get people to start doing climate resilience work in their backyards? And then up on the y-axis here is it really strong in its climate science content? Do people walk away from this with a better understanding of climate science? And what's nice about this graph is that it shows that nothing was perfect. There were some things that performed really well at the climate science side of things, like the Science on a Sphere and the Cosmic Climate Cookbook, but didn't perform as well as some of these other things that influenced people's climate resilience behaviors, like the ready row homes, the hands-on kind of things, and the extreme event challenge. The lecture series actually performed the worst out of all of those things, and so that might be a lesson to learn, is that we need to invigorate our public talks with more of these sorts of visualization techniques and or hands-on related things. So if you want to reach out to me, here's my email address, jhoffman@snv.org. You can find me on social media. I usually am pretty active on Twitter @jer_science. And with that, I want to hand it over to my colleague, Justin, who's going to tell us a lot more about cooking up the Cosmic Climate Cookbook. Justin.
All right, thanks, Jeremy, and thanks, Margaret, for that introduction. There's a visual transition, so it must be time for new presenter. Jeremy, you can go to the next slide. So already just today, you've heard a ton of information. Just a mountain of data is out there available to you. And there are a lot of factors you have to keep in mind if you want to present this in a planetarium setting. You know, you've got everything to think about from, we heard about, about a quarter of Americans aren't convinced this is happening. You've got, are you going to keep it as a national or even a worldwide picture? You've got the disparity between who's causing the problem, who's feeling the effects, and then some of the things we saw about trying to keep it local. When we tried to distill it down for the planetarium show, we kind of took a little different direction. Ultimately, what does the climate do for us? Well, a stable climate and one not so different from what we have right now on Earth. If that is maintained, it's really about keeping your planet habitable. So we on the next slide, we took a look at, if we really wanted to boil it down to a couple of points that people might be able to take away from the show, what short list of items should we talk about? So these I think we'll have to click through, but we decided that well, you got to have the right amount of energy incident on the planet. So in the introduction to the show, there's just a quick little run through of a lot of different stars out there. Some are hot, some are cool, some are bright, some are dim. Then next, we decided that, well, you've got to have some sort of atmosphere on the planet. I mean, the moon, not exactly habitable, so that's important. And then we realized there's just kind of a third ingredient in the recipe that we need to talk about. That was liquid water. That's pretty important for life here on Earth. And then in the making of the show, the fourth big ingredient was not actually talking about the Earth, at least not at first. So I kind of broke the show up into three different sections as it was being produced. And the first third of the show is a quick little primer on some of the basic facts about stars and then what atmospheres do for planets in general. Then we fly over to Venus. We talk about a few basic facts there and give kind of a quick recap of what things perhaps used to be like on Venus and how they have changed. And then we do the same thing at Mars, a few basic facts, look at how its climate may have changed over the history of the solar system. So we've got these two other nearby planets that, I guess you said Game of Floods earlier, made me think of Game of Thrones. So I guess by birthright, Venus and Mars, not so different from the Earth, right? But things took a very different course there. So with that behind us in the first third of the show, we're ready to go to the next section where we're really going to start setting the stage for what we're going to say about the Earth. And I did that in a couple of ways, took a few steps to get there. Once again, just kind of looked over the history of life on Earth, gave a nice relatable analogy for that. So we've got a history of the planet condensed onto a football field. It's a great animation that I didn't embed here, but we fly right down the football field to see when life develops a little past the 50-yard line. And then everything that has happened over the course of human history is on one blade of grass at the far end of the end zone. So could a civilization that's been around for such a short amount of time really have the kind of effects that we're talking about? Well, then the next step on the next slide is to talk about how we know some of this. So bringing in ice core data and how we can use that to analyze what's happened in the distant past. It's easy to talk about big ideas in the dome, right? A lot of the graphs and charts we've seen today are, localized on certain parts of the Earth, or just looking back a few decades. But we've got this grand canvas in the planetarium to use. So let's zoom out just a little bit. And what this kind of data allows us to do is, let's see, should be the next slide. we saw the levels of CO2 changing in the atmosphere over, Margaret, I think your slide was a couple thousand years. So here we went back 800,000 years, and you see some variations there. But as we get to 0,000 years ago, or the present day, again, just like the hockey stick graph earlier, this chart shoots up as well. And now we need to try and explain what that drastic change is. And this is a pretty interesting animation on a computer monitor like this. When that graph is 50 feet tall and the line shoots 2 stories above your head, and I think that's pretty impactful too. Now we're gonna, before we talk about how humans caused that big spike, we need to explain the first part of that graph. So there are these natural changes. Why was there that variation in most of the last 800,000 years? So I'm going to talk about some natural cycles here on the Earth. Ice ages, we talk about that and how different parts of the Earth, especially through the Great Lakes there, I see those getting buried in the Laurentide ice sheet. And that allowed us to pull in some really interesting information, something that I didn't know anything about until Jeremy introduced me to it. I know it's one of his favorites, and it's become one of my favorites too, the Milenkovic cycles. And so just like the visual transition in the PowerPoint background, the whole dome undergoes a little transition. If you go to the next slide, we're going to be in kind of a little virtual world, more of a sandbox here. We can just play with individual features of the Earth, again, over long periods of time. So there are 3 different aspects of the planet that are causing natural changes to climate on the planet. We've got just the Earth's obliquity, the tilt of its axis. So this is actually pulling real data and animating the Earth accurately over this time period. If I had to go back and remake the show, I'll probably do this in a very different way, but this is actually, I don't remember how many hundreds of individual Digistar commands actually tilt the Earth, but I've learned a few things in the last couple of years. So both about climate change and how to make planetarium software do stuff like that. But that was pretty good. And then we got precession, of course, which astronomically we're pretty familiar with. Then we've got the shape of the Earth's orbit as well. The eccentricity of Earth's orbit has been changing over long periods of time as well. So we actually animate that. And again, this is all based on real data, based on, or I guess real projections back in time, based on everything we know about all the sources of gravity and the laws of physics. So you put all that together, and next slide, Jeremy, I'm glad you had this animated in your talk, because I just grabbed the YouTube version of this that kind of combines all those natural cycles on the left to help explain why we have the ice ages and why there's some natural variation in Earth's climate. And I do have one more full dome slide of that. So you may notice this is actually different from the animation Jeremy had. So yes, the Earth is tilting the entire time. This visualization, the ice ages are running, precession is running, the eccentricity of Earth's orbit is running, and the whole room is rotating around you. So you're just really immersed in all these natural changes. And hopefully that's somewhat convincing, but we've still got one last step to take. So now I've got the last third of the show really just pile in some of the climate data that you've already been seeing and others that really help show that it's us that are causing a lot, it's driving this drastic change. So volcanoes were mentioned earlier by Margaret, and so we talked about briefly how yes, those spew aerosols, but there's some heat trapping gases that are released as well, but human activities far outweigh volcanoes. And next, we've also got a lot of data on how you're seeing these temperature anomalies throughout the talks today. And so we animated all that. The chart is animated on the left. In the dome, you get globes kind of all around you that show some of those yearly variations. I think on the next slide, I've returned to the show in subsequent years, and we see now the last 6 years. They're all the hottest on record. So and we can go to the decades as well on the next slide. So again, just more and more data. It's all available to us. So sharing it in a nice big format. So we got all the data, and then the show wraps up. There's a little call to action in there. Some of the same kind of stuff that you've heard today. You know, some policy changes. There's some personal changes you can make as well. So all that's in the show. But it's also pulling back the curtain a little bit. I'm going to drop the link in the comments in just a section, in just a second, so you can watch the show if you haven't already. But here's a little bit of what happened under the hood. It's a lot of content. It's right under 30 minutes on the dome. Yeah, 32 gigs. Just a few hundred files for Digistar users. I can send a content package to you. I know I've sent it out to Cranbrook, and we had to make some slight adjustments to make it work. But it is shareable that way. Off and on, I've been working on getting it into a Dome master format so we can send it to everybody. There are, because of some of the ways that I made some of the magic happen, it's a little tricky to capture some of those frames accurately, so I'm still working out some bugs. A lot of those 1,200 files come from NOAA. So we've got next, certainly Science on a Sphere. Yes, you can use those data sets on Science on a Sphere, but they work great on planets and globe primitives and planetarium software. I found a lot of similar data sets, and I think sometimes in better formats, depending on at least your resolution. On another NOAA resource, NOAA View, you can still access all kinds of surface, atmosphere, and ocean temperature data here, and you can download a lot of those in up to 4 or 8K, depending on the data we're looking at. And just on the next slide, I don't remember if they all come. Oh, good, they all come up at the same time. I kind of talk about breaking the show up into 3 different sections. Here are the ends of the 3 Digistar scripts that make those 3 sections happen. So just a few lines of code. And with that, I think we're at the credits. So Jeremy, you can jump to the next slide. Those will play. And while those are playing, I've got time to put some things in the chat. So a direct link right to the show if you haven't watched it yet. Again, that'll be the cropped down 16:9 version. If you're familiar with some of those big resources that we used, I got those links in there as well. And so there you go. That's the Cosmic Climate Cookbook.
All right. So that's Justin, we did have a question from Patrick. Hey Patrick, been a while. He was curious if it would work on D7.
It should, yeah.
Well, we're happy to answer any questions, ins and outs of, anything you heard today. And, certainly if we can be a resource, we'd love to be.
There was a question earlier on by Jim. He doesn't want to become cynical, but how can we expect much progress nationally when many people wouldn't wear masks to protect their health and the health of their family and friends?
Yeah.
I'd like to point out that we are beating the pandemic. And I think the majority people are wearing masks, and the majority people are getting the vaccine. I think we're over 50% for the first dose. And infections and deaths are down incredibly. I think that we can be hopeful because a majority care and are going to do something about it. That's my thought. Go ahead, Jeremy. I'm sorry I interrupted.
Yeah, no. I would agree. Sometimes it's we focus our attention on the very loud, small group of individuals that are extremely dismissive, or even nefariously denialistic about the approach that we should be taking. That group is getting smaller and smaller. Actually, Margaret shared with you the climate opinion maps. A majority of Americans, I think it's like 60% now, are at least agree about the problem. It's real, it's happening, that sort of thing. So we have tipped that kind of majority scale. I also think that we're still there's maybe still this idea that they're far away in time and place impacts, where it's really what we've found in our work is that we can accelerate climate action by making relevant local connections to things like housing or transportation or food or public health. And though all of those things, which are intimately linked to climate change, become the center of the conversation. And so we can actually do climate action without necessarily calling it climate action. And so I think that understanding those sorts of connections is really big for my own sanity as a, practicing climate scientist that tries to get folks to glom around climate action. I need to figure out new and innovative ways to connect the dots for folks that might be otherwise disengaged.
I guess I have a question. I might be the only person here with an optomechanical machine as opposed to a digital machine. However, that is a thing, and I do run a planetarium at a university. Do you have any advice about reaching out to NGOs in the community who can make those very concrete issues relevant to an astronomical context?
Yeah, Justin, do you want to speak to that, or do you have? I mean, I'm happy to at least offer my thoughts, but I would let you lead as the planetarium guy.
Yeah, I would have to think about it a little bit though. Yeah, it is a little trickier if it's the power of the data to be able to see some of these visuals that I think will really help. I mean, there's no reason that some of it couldn't be done with an inset projector or slides. It just would take some time to transfer it to that format.
No, I meant the connections. So I love the idea of having activities that we host activities for maybe, adults, members of the public, maybe children, I'm not sure. But it would be useful and proper to involve other stakeholders in the community. I'm just wondering if you have suggestions about to whom to reach out.
Yeah, that's a tough. Wait, somebody wanted. Oh, well, so that is hard sometimes to know where to start. In my experience, it is the sorts of environmental associations that might be in the existing, like the local Sierra Club, the local tree steward group, the local horticulture group, the master gardeners, the food access people. I mean, it really is an exercise of your own understanding of what are boundary organizations that might already be doing stuff, and like doing a mapping exercise of your own city. Like, who are those groups that are doing bus transportation, electric vehicles, renewable energy. All of those groups are looking for new ways to connect to different people, and folks that might be coming to the planetarium and folks that might be involved in their mission, there might not be a lot of overlap. And so it's a way for your organization to offer your space and your time and your effort to amplify their mission that becomes like a really authentic through time.
Okay, thank you.
Oh, Audubon's another good one. Yes, Susan, just any of those groups that are really interested in some sort of living organism or anything, and like doctors, there's like, clinicians for climate action groups in different places, allergists. Like, I mean, it really is an exercise in just thinking of like all the cascading impacts of what Margaret shared, all those data. Where does that impact us in our day-to-day lives, and how can we start to connect the astronomical to the on the ground kind of experience?
I have a question for Margaret. You were talking about the influence of the Clean Air Act, and I got to admit I overlooked all that stuff. And you were suggesting that the mid-50s cooling, it was a cooling that was attributable to the air pollution. And first of all, I just want to clarify: do the data show it's actually dipping down with the air pollution, or does it show that the rise wasn't as great? That was my one question. But the thing that I thought was great is the power of data to show the impact of legislation. Now, part of it is, the argument is, well, one of the things we can do is legislate, but here you're using the data for a different reason to show here's what legislation can do. Here's what it's done in the past where it has made global improvements that we can now measure.
Do you remember that Great Lakes web app where you could look at the temperatures for every location by decade?
Right. Detroit was like 3.5.
But you can show it dipping down in that one. So the graphic I was showing you was comparing a 30-year data set to the 21st century normal, 20th century normal. But if you go to that web app and pick one location or the whole region and just pick like the 40s to the, well, anyways, pick the decades, you can see before the Clean Air Act kicks in that, there's cooling at several locations.
And you're making a direct link to the Clean Air Act. The data
I am. I haven't done any research to do it, but a lot of people, it's been pointed to in other articles, and there was a lot of air pollution, and it was reflecting solar energy, and it was causing cooling.
So that dip, though, is attributable at least to the air pollution, then, which is attributable to back up to the Clean Air Act. Okay, thank you. And then another question, thank you very much. And another question I had, if I may, for Jeremy, is I'm really enjoy seeing all the different things like the role playing and the Prepareathon and things like that. Who's the audience that shows up for those more involved things?
Well, that's a really good question, and there's a kind of two-part answer. It depends on if it's free, and it depends on if you serve food and booze. So we purposefully made those events for adults only. We wanted it to be an adult audience. So we reached out through our kind of partners and stuff for recruiting participants, both when then we offered it as a free experience, and then we offered it as you have to pay $5 or whatever. We saw a lot more attrition. People just wouldn't show up if it was free. And then when we charged for it, more people showed up. And when we charged for it and you got food and drinks, not necessarily alcohol, but I mean, just offering light food and drinks, that was an attraction for a bunch of people. So when we had, people, and it turned out, if we got a big turnout, then people would tell their friends about it. And we got people by word of mouth to come back the second time. So that, as far as the types of people, it was really broad and varied. And one of the more diverse after hours experiences that we've actually offered. So we would have folks that saw themselves as like interested in extreme event sort of stuff. We also got like people from different organizations when we would collaborate with an organization on it. So for example, one of the things we did a rain barrel workshop along with the extreme event challenge. So people got to bring home a free rain barrel. So more people, the more ways, again, this goes back to how many ways can you tie the strings together for people to see this climate work or this climate stuff as my garden or my backyard, my daily commute. When you start to connect those things, people show up maybe for that other thing that they derivatively leave with more climate science information than they had before.
And for everybody, all the planetariums in this audience right now, how does the planetarium community do more as far as climate justice? That we're talking about an audience that doesn't have a lot of things that we typically are appealing to, who don't have their garden in the rain barrel and things like that. how do we address climate justice issues as planetarians?
I do think, Chuck, that the point is to build partnerships with people who in our communities who are affected. So water, for example, in Milwaukee is an issue. We have rivers and a lake nearby, and the quality of the water has improved because of local work. But that seems to be an issue that's still very relevant to members of our community. So if we could bring them to our dome to talk about, water in the cosmos, including your backyard. I'm making stuff up now, but I think that is a way of thinking, talking with other people and seeing, let's see, how can we work together? So I'm really interested in food. I'm a real foodie and I love to cook. So I'm trying to figure out also how to get more people of color in the planetarium and thinking about careers in science. So I'm thinking about how to connect food with astronomy, with climate change.
I will say that in my previous job, I worked at a planetarium in a largely Hispanic community, a lot of farm workers, and we put on a Science Day event that we intentionally made free and geared toward that community, and had food and drink, like you're saying, and had them bring their own cultural, art groups, and did, dances. So the whole family would come, and you'd have 3 generations who wouldn't come to a science event necessarily, but that would come to something like this that was, kind of marketed towards them. So yeah, I understand what Jeremy's talking about, with what audience they were trying to attract, and free wasn't the best option, but it could be for some others.
I have a question for Margaret. I work in a planetarium in a very politically conservative area in South Carolina. And I have been told that I can't say human-caused global warming. I just say climate change. But no matter how conservative people are, they trust the NOAA. And I was just wondering what you all have to say about, is there an official statement about human-caused global warming that I might be able to use? I like some of the things people are saying about maybe sneaking in other ways.
Well, I think Jeremy already pointed to this a teeny bit about finding the things that people in your community really care about and just tie it in with that. Some official statements, remember the IPCC, those overarching, or the National Climate Assessment, that NOAA is part of that. It's not a NOAA quote, but the National Climate Assessment was started by Bush in the Bush administration. The fact that we have to do this was started by conservatives,
Yeah.
which is great. So I think you can stick to the facts. And then I think what Jeremy suggested, you just try to avoid climate change, global warming. You can just say change and warming. And you could say, I think people are aware of the new climate normals.
Yeah, I don't think anybody doubts that the climate is changing, but it's strange that they refuse to accept humans as leading to that. I gave a talk about the Milenkovic cycles, and that global warming is not, or that the recent temperature rises are not due to Milenkovic. But that was as far as I was allowed to go.
Well, it has been shown that some people are so entrenched in not willing to negotiate or change their mind or hear facts. It's almost better not to engage with them too much. Doesn't mean you can't do your programming, but you don't have to get into it with them. That's what I think. I'd love to hear what Jeremy or Justin think about that, or anyone else.
Well, I think there's a lot of ways to talk about this in a way that is not so what some people have this place attachment theory, which would suggest that, and you can actually get this thing called reactance in, especially when you're challenging what people perceive as a freedom. And in many ways, what mainstream messaging sometimes around climate change is, you need to, people fear that means stop driving your car. We're going to make it, illegal to have a car, or, eat red meat, or whatever it is. It is, so sometimes that reaction comes from a values perspective more than an actual, what folks value in their day-to-day lives feels threatened by climate action. And so what maybe an interesting way to consider doing your presentations is to introduce yourself and why it is that you care about the natural world, or why you care about your association with these issues, and humanize it. Then it's a conversation. It's not the big scientists in DC or something like that. It's you. It's you as a human that's living in this world, and we're going to have a conversation about the values that we have about the world around us, about our neighborhoods, about our families. Those sorts of things then are much easier ways into talking about climate action in not a strictly, carbon emissions kind of sense. You can get there eventually, but it's important. We can talk about more values-based things than we can other approaches.
I attended just before the pandemic hit a training up at the Pacific Science Center in Seattle. They had created a show in conjunction with a University of Washington researcher, and they're trying to spread this to other planetariums. It's all on pause now because of the last year. But they were trying to get us to model what they had done, which is presenting the data and having them act like scientists and come to their own conclusions. So I don't know how much of that you guys do, but for certain people, I think that could be a good approach too.
Yeah, Andy, I applied for the training, but my administration said I couldn't go.
Yeah, I'm just curious, Carol, how you personally handle it. I'm that's a tough position to be in. Who does this come down from, and how do you deal with it to audiences and on a personal, emotional level?
We are run by our county government, and I am not allowed to mention evolution either. And so I treat it in the same way. I couch my words. We bought We Are Stars, and I read a disclaimer word for word before each show and announce that disclaimer that the show mentions the Big Bang. And I've decided to try and look at climate change in the past as a way, but I'm from New York originally. I've drunken the Al Gore Kool-Aid, and I'm a big advocate, but everybody says it's because I am from the Northeast.
And I don't think the task is so much to change the minds of the minority who are the firm deniers, but to increase the active advocacy of the passive believers. So you got to pick your battles. And instead of getting those who don't believe, you're not going to convince them ever. Go to the ones who do believe, but try to get them more active.
Well, I'm eager to see this show, and we have a media globe, and I might have to cut it to bits, but it's interesting to me.
Well, thank you so much, everyone, for the engagement around this. And feel free to email us. We'll put my email in here again if you need any sort of help, videos, those sorts of things. Justin's by far the planetarium savant on our team, so he's definitely. And then Margaret's one of the most accessible scientists and really wants to find ways to connect these data with users. So we're all here to help, and just thrilled that you all were part of the discussion.
Yeah, I'm so impressed with this work you're doing, and appreciate the optimism that you expressed in response to Jim's question. And this is an ocean liner we're trying to turn, so it's a process.
And thank you to our speakers. Also, thank you, Gene Creighton, for your hosting this series of talks from the Great Lakes Planetarium Association.
Thank you. Thank you all for participating. Thank you for the speakers and your willingness to help in future. We might contact you again for more specifics. Thank you all for joining us.